All right, here we go with our first lesson on rotational motion. This lesson is going to focus on the kinematics aspect of rotation. And the one thing we want you to keep in mind as we go through rotation is that there's always going to be a parallels to what we did first semester when we did linear motion. So what you're going to see here on the left side is I'm going to present things that we did in linear kinematics, and then I'm going to compare them with what we're doing now in what's called rotational kinematics. So a lot of things are going to be very similar, but we're going to see some different variables that we're going to be using. Now, when we started linear motion, the first thing we said is we need to imagine there being a number line to describe the motion. And so we chose things so that typically a number line said that anything moving towards the right was going to be going in the positive direction, and anything moving to the left was going to be in the negative direction. We then talked about the concept of position on that number line, and we used the letter X to describe the position of an object. So for instance, on our number line above, we can say that we have an object that starts at the initial position, in this case XO equals 1, and maybe it moves over a period of time to a final position, which we call X final. In the world of rotation, instead of having things moving to the right or to the left, you're going to picture an object that is simply rotating, not necessarily moving forward or backward or along a number line, though that is possible. But for right now, just focus on something only rotating. So if I have an object that I say is rotating, and let's take it so it comes around and goes counterclockwise, like that, we might say that it's rotating in the positive direction. It might sound counterintuitive to call counterclockwise the positive direction, but that's just the standard and that's how it's done. Clockwise would therefore be called typically the negative direction. Though once again, this is just kind of the standard. You could create a situation where you have clockwise be the positive direction or counterclockwise be the negative direction, just like we could have a number line going to the left that is positive and going to the right is negative. That's just not considered standard. So when we measure position for something that is rotating, we might start it at an initial angular position. So right now, we might say that my blue line is at the 90-degree position. If I take that and I rotate the object, didn't do a great job, but you'll have to deal with it, to the new position, we might say that that position final is at 180 degrees. Now, so far this year, we have been using the Greek letter theta to represent angular measurements, and we're going to do the same, except now we're going to focus on calling it the angular position. So there's a position initial, an angular position initial, which would be theta initial, and there's going to be a final angular position, which is going to be theta final. And just like we found the displacement by doing delta x equals x final minus x initial, we're going to do delta theta equals theta final minus theta initial. Now, there's different ways to measure an amount of rotation. For the most part this year, we have been measuring angles in degrees, and that's one way to do this. You can also measure things in terms of their rotations. So you could say something is doing 0.5 revolutions every second or something like that if you're going to do angular speed. But we could measure what fraction of a turn something makes. But in this unit, we're also going to introduce the use of radians to make measurements. And we believe at this point everyone has talked about the radian system of measurement in their math class. And we're going to review that here. But if you are unfamiliar with that at all, please let me or Mrs. Schrader know and we can give you a little bit more assistance if you need it. So I'm going to stop this video for right now, upload that, and then we'll move into the next slide.